Hi, folks. With testing event-driven systems, I ran into a nice pattern and I thought I'd share. So here I have an event-driven system. I'm going to quickly see if I can hit the API. Like it says, okay, get all movies works. So what I did is I have everything started here. Whenever there is a non-idempotent request, like a put, an update, a post, a put, or a delete, we log out something to the console. So let's say we try to add something and then we get our HTTP response, that's fine. But also as a side effect, there's some event going on. It's logging something to the console like this. Let's see the update work. Okay, so we get the HTTP response, but also the event of the update is logged out to the console. And then let's do the delete. The movie one has been deleted, and it's going to tell us, okay, yeah, this has been deleted. Also, just to make things a little more complicated, because events can be very complicated, and this is pretty much nothing. Um, we are also logging everything out to a log file. So it will give you all the event information in its raw format, and it's going to write things there. If you look at how that's being done, so we set up Kafka here, that part doesn't matter. When we produce the event, when we get a certain topic, we are synchronously console logging something. So I'll show you what this is doing. Just the console log and then stringify and then write the file to wherever, right? So we have the Cypress test, and it's a simple CRUD operation. So we add something, a movie, we get everything. We do the update, we do the delete. Those are fine. Right? But we have this utility function here. Basically, what it's doing is in the background is checking that file. So I can show that real quick. So I'm using Cypress Math here from Web. It's important that this is all retriable. So we can't do things like then. So we have to do things like apply and map this from there. So all these commands will keep retrying the chain. So that's important. Like we can't do dot log, right? Anyhow, so what it's doing is reading that file. It's working on the data, parsing it, and then we have this little function here which makes the Kafka event into a more workable data, let's say. So that's what it does. So it reshapes it, and then it instead of getting all these topics, all this list of topics, it's going to get the one we're looking for. So we're going to filter by the topic name. So it could be like an update, create, or delete. And then we're going to look for this key, which is like the ID of the entity. So those two things, because you can't really like delete some the same thing twice, or like add the same thing twice, or you could update it twice. So I guess in there you'll get like an array of things. Anyway, so that's what the filter by topic is. So this check that we have here, a synchronous check, it's looking at things and then doing some assertion, and then it works pretty well, right? Like it's just, let's see, it runs it, right? It does the invoke, split, apply, and then it's checking some data. Like we can probably see some of this in the Kafka event. Let's make this a little smaller. So it's reading the file, right? It trimmed the data so we can see all that. Like it split it, right? It made it into an array. It shaped it again, and then see now we see the 4 events that happened, everything that's in the file, and then we do that filter applying thing that finds the filtering thing, and then in it does the assertion, right? Like does this object look like what they expect it to look like, and that's the assertion, right? So everything nice and fancy right now. So where it will fall apart is we make this instead of a synchronous file, right? As an asynchronous file, right? It could be like anything that's a little long is going to fail. So I will just go ahead and replace this guy with the asynchronous version. And all of a sudden, we'll see things start failing because the it will sometimes work, sometimes not. It won't be enough. Like so, you run into this thing quite often. Like it will retry running things, and if we make this timeout short, it's going to work more probably, right? So if this timeout here is like 0, I think it's going to work. And this is an entirely artificial simulation of an event-driven system. Right? So if it's 0, it's more likely to work, but the higher it is, the more likely that this don't seem to work. So when something like that happens, then our regular Cypress assertions, which won't be enough, right? Now we have to use recursion. So I will write the recursion version of the same thing. So this is a question I asked Gleb, and he gave a really neat answer. So this kind of became a pattern, and even write a blog post on it. So our predicate, now our basically, let's see what this does now. So our command. So the first one will be the command, and then this value, and then we'll have the predicate. So recursion. Okay, yes. So first is the command, right? Our command will be parse all that stuff. Our predicate / assertion will be whatever the spok is, and then that's it. So basically all we do is take this guy, yes, like that. So that's the predicate, like it parses it, right? And does it have what we're looking for? Okay, a command function and then the check. So command function is this, right? The check function will be whatever this is. So this is how we can easily convert like a regular assertion into a spok assertion. And this part into a recursion assertion. And this part can change, like you can do your simple thing there. I like to use spok because very concise. And then the command function is the same. Right? So if we do this then, right, that first one will always pass. Okay, and then we'll have to convert the rest of the other ones into recursion versions. Okay. Um, guess we'll have to enable this one. I'm pretty sure that the first portion wouldn't work if it was enabled. But, and that works even if we increase the timeout. Even then, like let's say it's a painful, more time taking like recursion event going on, it will still handle things, right? Like even if it takes a while writing to the file. All right, so this is a good pattern then to convert some of the um, like naive or easier checks into recursion so that they're more reliably working in event-driven environments. So